Hello everyone, in this video I'm going to talk about isomers. Isomers are chemical compounds that share the same molecular formula but differ in the arrangement of their atoms. This difference in arrangement leads to distinct chemical and physical properties. Isomerization is the chemical process by which a molecule is transformed into an isomer with a different chemical structure. This often involves the rearrangement of atoms or groups of atoms within the molecule without changing the overall molecular formula. Isomerization reactions can occur spontaneously or be induced by heat, light, or catalysts. A common example in the petrochemical industry is the conversion of straight-chain hydrocarbons into branched-chain isomers, which improves gasoline quality. In this video, we are going to discuss two types of isomers: structural or constitutional isomers and geometric isomers. First, let's talk about structural isomers. Structural isomers are compounds that have the same molecular formula but differ in the way their atoms are connected or bonded to each other. Their connectivity is different, leading to different structural formulas. For example, pentane, 2-methylbutane, and 2,2-dimethylpropane. The three of them have the molecular formula C5H12, but their carbon skeletons are arranged differently. Pentane is a straight-chain alkane with 5 carbon atoms connected in a continuous chain. Two-methylbutane has a 4-carbon chain with a methyl group attached to the second carbon atom. Two,2-dimethylpropane has a central carbon atom bonded to 4 methyl groups. It has the most branched structure. These three compounds are structural isomers of each other because their atoms are connected in different sequences, resulting in different shapes and physical properties like boiling points. The more branched the structural isomer, the lower its boiling point. So pentane has the highest boiling point, followed by 2-methylbutane and then 2,2-dimethylpropane, reflecting the decreasing surface area and thus weaker intermolecular forces. Now let's talk about geometric isomers. Geometric isomers or cis-trans isomers are compounds that have the same molecular formula and the same connectivity of atoms, but differ in the spatial arrangement of their atoms around a rigid bond or a ring structure. The most common type of geometric isomers occurs around a carbon-carbon double bond, because the double bond prevents free rotation of the atoms. For geometric isomerism to occur around a double bond, each carbon atom involved in the double bond must be attached to 2 different groups. In the cis isomer, the 2 similar groups are on the same side of the double bond, while in the trans isomer, the 2 similar groups are on opposite sides of the double bond. For example, the 1,2-dichloroethene has the molecular formula C2H2Cl2. The 2 carbon atoms are joined by a double bond, and each carbon is bonded to 1 hydrogen atom and 1 chlorine atom. They can be arranged in 2 different ways. The first one is cis-1,2-dichloroethene. In this isomer, both chlorine atoms are on the same side of the carbon-carbon double bond. The second one is the trans-1,2-dichloroethene. In this isomer, the 2 chlorine atoms are on opposite sides of the carbon-carbon double bond. These 2 compounds are geometric isomers because their atoms are arranged differently in space due to the restricted rotation of the double bond. They exhibit different physical properties such as boiling points. The cis isomers generally have higher boiling points than their trans counterparts. So cis-1,2-dichloroethene has a higher boiling point than that of trans-1,2-dichloroethene. That's it. Thanks for watching.